Welcome to the Aquatera Wastewater Treatment Plant. Our treatment plant facilities employ approximately 30 staff consisting of operations, millwrights, electricians, instrumentation techs, administration, and safety staff. Our staff ensure treated wastewater effluent is sent back to the Wapiti River, as well as ensure safe, reliable drinking water to our regional system. In some instances, we also provide remote operator assistance to other communities within Alberta. In 1984, the City of Grand Prairie began processing incoming wastewater and the mechanical wastewater treatment plant. The existing wastewater treatment plant processes an average of 19 million liters of raw wastewater per day, and with the upgrades that were completed in 2016, we can now process up to 36 million liters of water per day. Human waste, nitrogen ammonia, and phosphorus are all food nutrients for bad bacteria and algae. If organic matter is released into the environment without treatment, it will act as an extra food source for bad bacteria when they are already populating river systems. This will cause an overbalance in the ecosystem, and microorganisms will excessively reproduce using up dissolved oxygen in the river. Raw wastewater is transported to the wastewater treatment plant by an underground collection system. A level sensor located in a metering chamber measures the volume of raw wastewater coming into the plant. This sensor relays information back to a control room for operators to review and process. As raw wastewater enters the plant, it is mechanically lifted from the collection system up to the plant's headworks room by screw pumps. These pumps resemble a corkscrew and are 30 feet long by 5.5 feet in diameter. When raw wastewater flow exceeds the screw pump's capacity, like during a major rainfall, the plant has the capability to divert up to 64 million liters of raw wastewater per day. This is done by using 3 equalization pumps. These pumps divert raw wastewater to a storage pond until a later time when it can then be returned back to the plant for treatment. This storage pond is capable of holding 150 million liters of extra raw wastewater. After the screw pumps have mechanically lifted the wastewater, it then flows through the wastewater treatment process by gravity. First, it enters the headworks room, which is outfitted with hydrogen sulfide and lower explosive limit sensors to continuously monitor the atmosphere. At this point, the wastewater enters one of 2 vortex grit separator units, where grit such as rock and heavy inorganic material is removed before the treatment process. The grit is then transferred to a collection bin, where it is transported to the Aquatera landfill for disposal. From the grit removal units, wastewater flows through step screens, which will remove any solids larger than 6 millimeters in size. Solids remaining within the screens will be compacted and transferred into a collection bin, where it is also transported to the Aquatera landfill for disposal. A composite sampler collects a sample of raw wastewater throughout the day from behind the step screens. The operator will gather this sample daily to perform laboratory tests. Next in the treatment process, wastewater flows into one of 2 rectangular primary clarifier tanks. These tanks are 15 feet deep and hold 1.5 million liters of wastewater each. The purpose of these clarifiers is to slow down the wastewater and allow time for heavier solids to settle out. The solids are then collected using sludge scraper units installed inside each clarifier. The collected solids are pumped through a grinder unit and over to the wastewater dissolved air flotation unit, otherwise known as DAF, for thickening and then disposal. Collection troughs located at the far end of the clarifier collect the wastewater and distribute it to 3 bioreactors. These 3 bioreactors are used for the activated sludge biological nutrient removal process. Each bioreactor tank is divided into 4 different zones: pre-anoxic zone, anaerobic zone, second anoxic zone, and the aerobic zone. The total volume of all 3 bioreactors is 14 million liters. When wastewater is mixed with microorganisms in the bioreactor, it is referred to as mixed liquor. At no point during the treatment process are chemicals introduced into the bioreactors themselves. The bioreactor process creates a perfect environment for microorganisms to treat the wastewater and remove various nutrients. The microorganisms feed on, absorb, or convert carbonaceous organic matter, or human waste, nitrogen ammonia, phosphorus, and total suspended solids from the wastewater. Air blowers supply oxygen through a piping and valve system into the aerated bioreactor cells. Located on the bottom of these cells is a grid system of fine air diffuser heads. Diffuser heads cause the air to be released into the wastewater as very small bubbles. This process dissolves the oxygen into the wastewater and microorganism mixture so the microorganisms can thrive and treat the wastewater. Dissolved oxygen probes located in each aerobic zone regulate air blower valves which allow more oxygen to enter into the bioreactor zones when required. Located at the end of the aerobic zones within the bioreactors, a certain amount of wastewater, referred to as waste-activated sludge, is pumped to the wastewater DAF unit, or rotating drum thickener, for solids thickening. The purpose of removing a portion of microorganisms from the treatment process, around 5% daily, is to ensure that a balance of bacteria within the bioreactors is maintained. Under normal conditions, a bacteria used to treat wastewater will reproduce every 30 to 60 minutes. If the waste-activated sludge system were not in place, excessive amounts of bacteria would reproduce and full treatment of the wastewater would not take place. Mixed liquor from the 3 bioreactors flow into a piping system underground. The piping from all 3 of the bioreactors combines into a 6-foot pipe and then flows into a flow-splitting chamber to be separated into 2 secondary clarifiers. The flow-splitting chamber will direct the mixed liquor into one of 2 secondary clarifiers. This chamber is equipped with slide gate valves to isolate the clarifiers for repair, servicing, or inspection. Each clarifier is over 100 feet in diameter and can hold 3.5 million liters of wastewater. The purpose of the secondary clarifiers is to allow settling of the mixed liquor in order to separate out the solid portion from treated wastewater. Solids and bacteria will combine together to form a large, heavy particle that settles to the bottom of the secondary clarifiers. Sludge scrapers move the settled bacteria and solids to the middle of the tank where it is recirculated back to the first bioreactor zone. The clean treated wastewater overflows into a collection trough located on the outside edge of the clarifier. The scrapers gather the scum, which then flows into a collection holding tank. From here, it is pumped back to the headworks of the plant, where it will go through the treatment process once again. The scum will be broken down and used as food for the microorganisms inside the bioreactors. Returned activated sludge pumps recirculate the microorganisms and solids that have settled to the bottom of the secondary clarifiers. These pumps transfer the settled bacteria to the first pre-anoxic zone of each of the 3 bioreactors, where it is mixed with raw wastewater and continues through the treatment process again. The clean, treated wastewater collected on the surface of the secondary clarifiers is referred to as treated plant effluent. The effluent travels by gravity through a 3-foot diameter pipe to a holding tank referred to as a wet well. Connected to the effluent wet well are 4 pumps that can be used in sequence to pump the effluent back to the Wapiti River. Sample lines are connected to the effluent discharge pipe to collect treated wastewater samples for daily laboratory testing. It takes roughly 33 hours from when the raw wastewater enters the plant to this final stage of discharging effluent back to the Wapiti River. West of the wastewater treatment plant is Aquatera's final effluent lagoon system. This lagoon system can store up to 1 billion liters of effluent. 3 final lagoon pumps are available to pump the effluent from the lagoon system to the Wapiti River. This process is used when there are plant shutdowns or process repairs that may disrupt wastewater treatment processes. Connected to the effluent line are 3 service water pumps. Treated plant effluent water is pumped throughout the plant for various operational applications, such as flush water for equipment, service water for the DAF units, and other various cleaning tasks. Beneath the surface of the plant is a maze of underground tunnels. These tunnels are used to provide an accessible area for the plant pumps, piping valves, flow meters, and other equipment used in the overall wastewater treatment process. Electrical rooms in the plant house the power distribution wires, electrical systems, and breakers for all the equipment throughout the plant. As discussed previously, the DAF unit will collect and thicken primary clarifier sludge and waste-activated sludge from the wastewater treatment plant. Polymer is added to the stream of primary sludge and waste-activated sludge to assist with the joining of solids. Recirculation water is combined with air. When this solution is released to atmospheric pressure, the air dissolved in the liquid is released and tiny microbubbles are created. These bubbles adhere to the solids, causing them to float to the surface, where a skimming unit will transport the floating solids to a collection tank. From here, the contents of the collection tank are pumped to digester tanks for sludge treatment. The wastewater left after the solids have been removed is referred to as subnatant. Subnatant is pumped back to the plant's headworks to pass through the treatment process again. Typically, sludge will be thickened between 3 to 6% by the DAF unit. As an alternative unit to the DAF, a rotating drum thickener was installed for the thickening process of primary clarifier sludge and waste-activated sludge. Polymer is added into a mixing tank where primary clarifier sludge and waste-activated sludge are pumped. The solution then flows into a large rotating drum, which is 5 feet in diameter and 12 feet long. The rotation drum thickener's outer frame is covered in screen filtration panels, and as the drum rotates, wastewater is drained through screens, leaving a thickened sludge inside. Spray bars clean the drum screens periodically, allowing the wastewater portion of the solution to flow through the screens. The thickened sludge drops down into the DAF unit trough, where it is pumped to digester tanks for sludge treatment. The wastewater portion of this solution is pumped back to the plant's headworks to pass through the treatment process again. Typically, sludge will be thickened to 3 to 6% by the rotation drum thickener. Solids collected in the water treatment plant from desludging of the sedimentation tanks, as well as from filter backwashes, are stored in an underground holding tank. This solution is then pumped to the wastewater treatment plant. The DAF unit will then thicken the solids and pump them to the sludge holding tank for storage and further solids dewatering by the centrifuge. There are 2 DAF units available to assist with extra solids loading from spring runoff and heavy rain in the summer months. An autothermal thermophilic aerobic digester reactor tank, or ATAD, collects the thickened primary clarifier sludge and waste-activated sludge from the thickening process. In total, there are 3 ATAD reactors and 1 storage tank that will treat the sludge through the thermophilic digestion. Each ATAD will hold 460,000 liters of thickened sludge, and the storage tank will hold 290 liters of sludge waiting to be dewatered by the centrifuge. After ATAD treatment, the sludge will then be dewatered by the centrifuge and transported to Aquatera's landfill to be used for cover material. Digested sludge is pumped from an ATAD storage tank to the centrifuge building, where the sludge is mixed with a polymer to assist solids in forming a larger particle. This mixture is fed into one of two centrifuges. The larger centrifuge can efficiently dewater up to 65,000 liters of sludge per hour to 30% dry solid content. The smaller centrifuge can dewater up to 25,000 liters per hour. Both centrifuges use the concept of centrifugal force to promote the separation of solids from liquids. The G-force inside the spinning bowl forces the sludge to the outer edge where the liquid portions separate from the solid portions. The liquid is removed and flows back to the plant's headworks, while the solids are gathered up using a screw conveyor. The dewatered sludge is forced out by the conveyor to a drop chute located at the bottom of the centrifuge. The solids fall into a dump truck to be transported to the Aquatera landfill and used for cover material. Off gases collected from the ATAD tanks are very high in ammonia concentration. The gas is collected on the top of the ATAD tanks and transported to a cooling tower vessel. Service water is sprayed on the warm gas passing through plastic media, where nitrification bacteria living on the media will assist in the removal of the ammonia. The gas then travels through a biofilter using a sequence of air blowers. Service water is sprayed on a wood chip layer where bacteria will remove another portion of ammonia. In the last step of ATAD, off gas is combined with outside air at the bioreactor blower. The blower pushes the air to diffusers inside the bioreactor where the ammonia combines with the wastewater. Air from the headworks, grit, and centrifuge rooms are treated for odors by passing through one of two activated carbon tanks. Aquatera also accepts septic and sump material trucked from surrounding businesses and areas. At the septic receiving station, vac trucks connect to a line where the wastewater is metered and flows through a collection system to the wastewater treatment plant for processing. Roughly 45 million liters of wastewater is brought to the plant annually for treatment. At the sump receiving station, trucks bring a slurry of loaded solid material which is weighed at a truck scale prior to disposal. The sump material is dumped from the truck into a holding cell. The trucks then head back onto the truck scale, where a final weight is recorded for billing. Aquatera's water and wastewater treatment plant operators monitor every component of the treatment process in the control room. Monitoring systems provide real-time and valuable data to the operators. Audible alarms inform operators when issues arise within the treatment process, such as when pumps stop working or there is a disruption in the process. Operators are able to review the status of pressures, pumps, flows, and equipment at all times. Operators can also make plant changes through the control room computer system. The quality of the treated plant effluent that will be returned to the Wapiti River is continuously treated and inspected by our operators. Some of the tests performed include pH, total suspended solids, biological oxygen demand, phosphorus, nitrogen ammonia, nitrate, nitrite, and total Hendel nitrogen. Testing the mixed liquor and bacteria that are inside of the bioreactors is also important to the operation. These tests include sludge volume index, mixed liquor suspended solids, mixed liquor volatile suspended solids, and food to microorganism ratio. These tests will help determine how the sludge will settle within the secondary clarifiers, the amount of inorganic matter to bacteria in the bioreactors, and the amount of food available for the microorganisms to consume and reproduce throughout the treatment process. Testing pertaining to the water treatment plant is also conducted in this laboratory. Safety is a priority for all employees and contractors working on site. The wastewater treatment plant can be hazardous during day-to-day operations. Operators are required to take safety courses to ensure that they can correctly and safely perform tasks associated with their jobs. Online monitors are located in hazardous areas of the treatment plant and will notify operators if building atmospheres become unsafe. Operators wear a wide range of personal protective equipment throughout the wastewater treatment plant for their protection. No job should ever be important enough to sacrifice safety. Here is an example of what the wastewater treatment plant accomplishes. On the left is raw wastewater. On the right is treated plant effluent. Returning clean and environmentally safe wastewater back to the Wapiti River is every operator's goal at Aquatera. Aquatera, helping grow healthy communities.